Now we will be discussing the energy profile diagrams. To understand, there are two steps. Why is there a slow step and why is there a fast step? The general mechanism can be written as, जे साढ़े को एक benzene ring है जिसके ऊपर ग्रुप G लगा हुआ है, G can be activating or deactivating. In the first step, electrophile gets electrons from the ring and it is substituted at ortho, meta or para position. Now this is the sigma complex formed. If the G is an activating group, then electrophile is added at either at ortho position or at para position. If group is a deactivating group like NO2 group, then electrophile is substituted at meta position. Now this is the slow step, and we know slow step is also known as rate determining step. This reaction intermediate in which the aromatic character of the benzene ring breaks down, it is stabilized by resonance. This is known as sigma complex or cyclohexadienyl cation. But a very fast change हो जाता है into the final product. क्यों? So that the aromatic character of the ring is restored and there is a removal of a proton from the same carbon on which electrophile is added. ਤਾਂ ਇਹ slow step ਕਿਉਂ ਹੈ, ਇਹ fast step ਕਿਉਂ ਹੈ, ਇਹਨੂੰ ਅਸੀਂ better understand ਕਰ ਸਕਦੇ ਹਾਂ ਜੇ ਅਸੀਂ ਇਹਨਾਂ ਦੇ energy profile diagrams ਦੇਖੀਏ. Now look at the general energy profile diagram. There is a benzene ring which is substituted with a group. So to get converted into a sigma complex, we have to supply energy which is called energy of activation. So it goes through the first transition state, converts into sigma complex fast converts into the final products. Now look at ਜਿਹੜੀ पहले step the energy of activation है वो ज़्यादा है to form a sigma complex. So the first step is the slow step. ਜਿਹੜਾ second step है ਇਹਦੀ energy of activation ਘੱਟ ਹੈ, ਇਹਨੂੰ ਇਹਦੇ ਵਿੱਚ convert ਕਰਨਾ, it is a fast step. So this reaction intermediate or the sigma complex ਇਹ closely resemble ਕਰਦਾ transition state ਦੇ ਨਾਲ. ਇਹ ਅਸੀਂ according to Hammond's postulate we say that this is closer to the transition state. Now this is the overall thing. Now we will understand how, if there is a activating group, what is the energy profile diagram. If G is a deactivating group, then what is the energy profile diagram. ਤਾਂ ਅਸੀਂ discuss ਕਰਾਂਗੇ ਸਿਰਫ sigma complex ਤੱਕ ਕਿ how the dynamics of the energy changes. Now look at this diagram. ਇੱਥੇ ਅਸੀਂ ਦੇਖਦੇ ਹਾਂ ਕਿ benzene ਦੇ ਉੱਪਰ एक electron releasing group लगा हुआ है and we know methyl group is a activating group. And look at this is the first transition state. ये जड़ा sigma complex बने हैं, this will involve formation of a meta product. Formation of meta product requires higher energy, but for formation of ortho or para product, energy of activation is low. Energy of activation क्यों घट है? Because we have a electron releasing group. Positive charge ਨੂੰ stabilize करता है methyl group. Positive charge ਨੂੰ methyl group stabilize कर रहा है. So इस करके methyl है जेड़ा, it is ortho and para directing group, and ortho and para products are formed in higher amount. Now look at if there is a deactivating group. ਅਸੀਂ ਜਾਣਦੇ ਹਾਂ nitro group is a deactivating group. It shows minus I effect as well as minus R effect. Now look at this transition state. Formation of ortho product or para product. Any energy of activation ज़्यादा है. It requires a higher energy of activation as compared to formation of meta product. उन्हें difference क्यों है? जे ऑर्थो जहाँ पैरा के ऊपर इलेक्ट्रोफाइल लग गया तो उस कार्बन के ऊपर पॉजिटिव चार्ज है जिदे नाल एक NO2 ग्रुप लग गया है which shows minus I and minus R effect. ਤਾਂ ਇਹਨਾਂ ਦੋਨਾਂ ਨੂੰ ਇਹ ਘੱਟ ਸਟੇਬਲ ਕਰਦਾ ਮੀਨਸ ਇਹਨਾਂ ਦੀ એનર્ਜੀ ਜ਼ਿਆਦਾ ਹੁੰਦੀ ਹੈ ਤਾਂ ਆਟੋਮੈਟਿਕਲੀ ਜੇ ਮੈਟਾ ਸਬਸਟੀਟਿਊਸ਼ਨ ਹੋਏਗੀ ਤਾਂ ਜਿਹੜਾ ਸਿਗਮਾ ਕੰਪਲੈਕਸ ਬਣੇਗਾ ਇਹਦੀ એનર્ਜੀ ਘੱਟ ਹੋਏਗੀ ਸੋ ਦਿਸ ਵੇ ਵੀ ਕੈਨ ਅੰਡਰਸਟੈਂਡ ਦੀ ਓਵਰਆਲ ਰਿਐਕਸ਼ਨ what is the energy profile diagram ਤੇ ਇਹਦੇ ਨਾਲ ਆਪਾਂ ਕਿਵੇਂ ਐਕਸਪਲੇਨ ਕਰ ਸਕਦੇ ਹਾਂ formation of ortho product meta product or para product we also better understand with the energy level diagrams that how activating group and deactivating groups affect the energy of activation of for formation of a sigma complex.